Hello grade 6, how are you today? I hope you are fine. Today we are going to study solving first degree equations in one unknown. But before we start, we have to remember that the equation which contains one unknown and this unknown powered by 1 is called first degree equation in one unknown. First degree equation in one unknown. And to solve this equation, we have to find the value of this unknown. The value of the unknown. And the value of this unknown called the solution of the equation. The solution of the equation. And we can find the solution easily if we have a substitution set. But it is impossible to find the solution of the equation if the substitution set is an infinite set. So we have to learn some probabilities. So we have to learn some probabilities to solving the equations easily. The first one of these probabilities, an equation remains valid if we add the same number to the both sides. An equation remains valid if we add the same number to the both sides. An equation remains valid if we added the same number to the both sides. For example, if we have this equation, x minus 2 equals 5. So x here equals 7. Because 7, the unique number, if we subtracted 2 from them, gives 5. So x here equals 7. And now, if we add 2 to the both sides of this equation, the left-hand side equals x. Negative 2 plus 2 equals 0, and x minus 0 equals x. 5 plus 2 equals 7. So x equals 7. Notice that the value of x in the two ways are equal. So we can add the same number to the both sides in equation without change the value of the unknown. The third probability, talking about an equation remains valid if we subtract the same number from the both sides. An equation remains valid if we subtracted the same number from the both sides. For example, if we have this equation, x plus 3 equals 2. So the value of x here equals negative 1, because negative 1 is the unique number. If we add to 3, gives 2. So x here equals negative 1. By another way, if we subtract the number 3 from the both sides, 3 minus 3 equals 0, and x plus 0 equals x. 2 minus 3 equals negative 1. So the value of x equals negative 1. Note that the value of x is not changed in the two ways. So an equation remains valid if we subtracted the same number from the both sides. The third probability, talking about an equation remains valid if we multiply it by the same number. For example, if we have this equation, x over 2 equals 3. Now, if we multiplied the two sides by 2, two over 2 equals 1. So the left hand side equals x and the right hand side equals 6. In other way, 6 is the unique number. If we divide it by 2, it gives 3. So an equation remains valid if we multiply the both sides by the same number. The last one, an equation remains valid if we divided the both sides by the same number. For example, if we have this equation, 3x equals 9. The value of unknown in this equation equals 3, because the number 3 is the unique number. If we multiply it by 3 equals 9. So x equals 3. X equals 3. By another way, if we divide the two sides by 3, three over 3 equals 1. So the left hand side equals x and 9 divided by 3 equals 3. So the value of x equals 3. The value of x is not changing. So an equation remains valid if we divided the both sides by the same number. And in general, we can say that if we have the numbers a, b, and c, so we have these probabilities. If a equal b, so a plus c equals b plus c. And if a equals b, so a minus c equals b minus c. And if a equals b, so a multiplied by c equals b multiplied by c. And if a equals b, so a divided by c equals b divided by c. This is the probabilities. And now let's try to solve some exercises. Exercise 1. Find the solution set of each of the following equations in the set of integer numbers. A. 4x minus 3 equals 13. If we need to find the solution of this equation, we have to find the value of this unknown. So in the beginning, we can add the number 3 in the both sides. So 4x minus 3 plus 3 equals 13 plus 3. Negative 3 plus 3 equals 0. 0 plus 4x equals 4x. So the left hand side equals 4x. The right hand side equals 13 plus 3. 13 plus 3 equals 16. And now we have 4 multiplied by the unknown x. So we need to divide the both sides by 4. Four x divided by 4 equals x. So the left hand side equals x. And 16 divided by 4 equals 4. So the value of x equals 4. When the value of x equals 4, the solution set of this equation equals the set of number 4. And now, what about the equation b? To solve equation b, x over 3 plus 5 equals 2, we have to subtracting 5 from the both sides and multiply the both sides by 3. X over 3 plus 5 minus 5 equals 2 minus 5. 5 minus 5 equals 0. So the left hand side equals x over 3. And the right hand side equals 2 minus 5. 2 minus 5 equals negative 3. Negative 3. And now we need to multiply the both sides by 3. The left hand side equals 3 over 3 times x. So the left hand side equals x. And the right hand side equals negative 3 times 3. Negative 3 times 3 equals negative 9. So the value of x equals negative 9. So the solution set of this equation equals the set of number negative 9. Exercise 2. Find the solution set of the equation 5x plus 3 equals negative 2 in each of the set of natural numbers and the set of integer numbers. Equation is 5x plus 3 equals negative 2. So we need to subtract the number 3 from the both sides and divided the both sides by 5. Let's start with subtracted. The left hand side equals 5x plus 3 minus 3. 3 minus 3 equals 0 and 5x plus 0 equals 5x. So the left hand side equals 5x. The right hand side equals negative 2 minus negative 3. Negative 2 minus negative 3. And negative 2 minus negative 3 equals negative 5. So we need to divide the both sides by 5. Five x divided by 5 equals x, and negative 5 divided by 5 equals negative 1. So the value of x equals negative 1. And now let's try to find the solution set in the set of natural numbers and the set of integer numbers. In set of natural numbers, the solution set of this equation equals the set of negative 2. Is it right? Of course not, because the set of natural numbers not contains the negative numbers. So negative 2 is not a solution set for this equation in the set of natural numbers. So the solution set in the set of natural numbers equals the empty set, or phi. In the set of integer numbers, the solution set of this equation equals the set of negative 1, because the set of integer numbers contains the negative numbers. So the solution set of this equation in the set of natural numbers equals phi, and the solution set of this equation in the set of integer numbers equals negative 1. By the end of the lesson, study hard and stay safe. Good luck.